Video streaming, video streaming through this thing.
Zoom it.
Yeah, through Zoom. For audio, no, we have to do something.
Audio.
From this audio.
Audio is coming from
The laptop, my
check from Zoom.
hello, hello, hello. Hello, 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 hello.
Guys, please settle down. We are going to start within 5 minutes. Guys at the back, please have a seat. Please come at the front. We're going to start within few seconds now, please. Yeah. So yes, we are going to start now. So how's the snacks? I hope everybody had. How is it? Good? Okay. So let's see the energy because we are just going to start the second phase of the talk. Let's check the energy. How is the energy, guys? How is the energy? No, nothing. It is very, this is, I mean, totally, I mean, not acceptable at all. Can we have one more, please? How's the energy, guys? Okay. So we'll move for the first speaker of the day right now. Sorry, not fourth, third speaker of the day. And his name is Ajay Lakshman. He is a full stack developer from FCL Australia. And he will talk about making React apps smarter with AI powered search. Can you please welcome him?
Yeah, hi everyone. I'm Ajay. I'm basically from Bangalore and I work as a full stack developer at FCL Australia. So, yeah, I have a pretty new tricky experience in React and AI. Recently, I discovered one of the interesting topics which I had to share with you guys. So, I mostly work on both front end and back end. So I had troubles like storing my data, which is huge. Uh, is any of them over here like in back end? Probably like back end and they store data into the database, like they want to do AI integrations. And have you ever wondered like how do we store like complex data and how does complex data is being retrieved or stored in the database? Does anyone know how it's done? Like like most of them has have studied about vectors, right? We all know vectors, like we all studied Java, of course. So what do we mean by vectors? Vectors is something which is very complex. Complex data and a set of floating numbers is what we can understand in basic. So my topic for the day is how do we make React apps smarter with AI? Like it's more like how we retrieve and store the data in the database and how we actually do complex queries and intentional based searching is what I can say. Like let's say we have ChatGPT and which is built by OpenAI, yes. So when we do like I have headache, ChatGPT, I have headache. And how does it know what to suggest? How does it give the phrase? How does it actually matches our intent? What we are saying and how does it give the result? And that's what we call as intentional based search, that is intent. And it is we can also call it as semantic search, which is what I'm going to be presenting to you guys today. Yeah. So why AI in search? Like, let's say we all have seen Google search, right? We all use it daily, every day. And when we type something like, let's say, OpenAI, just for an example, OpenAI, how does it work? The first thing which we see in the Google search after searching, making the search, right? In the results page, we see the paragraph being highlighted and that is being matched with the intent of what you're searching. If we search about just type React, and it returns the results of all the languages, libraries. So it returns Vue.js, React, and whatnot. So my friend Milind has already covered the topic regarding RAG and stuff like how he just explained how it works. So it is very similar to that, but how does it actually do in the backend is the problem. So like search is the main thing which we even develop in our own applications. We have search. Let's say we have an e-commerce store being built, we have a search. So there's a problem in the traditional database where we actually match the queries. Like let's say Apple, and it returns the query, searches for the results matching the word Apple. So that works only with tightly coupled data, like what we call as like when a product or something which is related to Apple only being returned. But what do we call fruit? If we call fruit, if it has a subcategory called food, it returns the data. But what if it doesn't have it? That's the problem. Like that's where intentional based search comes in. If we do fruits, it returns fruits, fruit based medicines. Like it relates to every data that is being searched. So that's why search is very important, and we nowadays use search for our own needs. Like in OpenAI, we use ChatGPT for everything nowadays. Like even for household stuff, and I recently explored in ChatGPT. If you are too emotional and want to say something to ChatGPT, right? And we software developers sometimes are very nerds and introverts. We talk to ChatGPT. So when we do that, like it actually supports us and gives us some emotions back, talking as a person. And how does it do that? It has like a collection of data which is being intentional based, and it understands and it matches the queries. How does it actually store that huge amount of data? Again, vectors. And I'll be covering in an easy, small way. It is a small and sweet topic. So we're gonna use like few API calls to be made. One for calling the embedding of the vectors, and another is just retrieving the data. These are the two things which you're gonna do to match the results and retrieve it. And yeah, we're going to use Pinecone and OpenAI. OpenAI, of course, it provides the results for us. Let's say I am Ajay. So this string called I am Ajay is converted to a vector-based array. Let's say highly complex multidimensional array of numbers. Let's say like we have like I am Ajay. Like I is converted to a set of floating numbers. It may be negative based on the embedding which we have done in OpenAI. So in the upcoming slides, I'll be explaining how does it actually work. But before that, I would like to cover like in a visual representation. Yeah, so yes, that's it. Yes. So what we see over here, NeonDB and Pinecone. And as we are talking about Pinecone, right? And this is a basic visual representation. Just before I get into technical stuff of how it actually works, we just query something. I need to search something, and the data is being embedded into a set of vectors representation, like into floating numbers, and then we store it in the Pinecone. What is Pinecone? Like Pinecone is something which is what we can call a vector-based database. It is a cloud storage, and the reason we use it. Yeah. So as I spoke, like keyword search is what the traditional way we do, and it is very rigid when it comes to unrelated keywords and whatever we have to search, and it misses like synonyms and the intention what we are trying to do. And we are searching for a doctor. We don't know what doctor. Yesterday, before even getting to know about this React topic, right? It's a very good example. I searched about it in a meetup and it was hosted in eka.care. So even before I knew about eka.care, I had some appointment to be done for myself and I searched for a psychologist. My friend had to search for a psychologist and it returned a set of doctors being registered in my area. Yeah, we all know Practo, but it got the result using ECAS, like, I had searched about ECA even before, like, searching for the doctor, but it had the intent to match with it. So it returned one of the doctors being registered with ECA. I was surprised by it. When I actually came over here, I searched about ECA.care in YouTube, and one of the doctors being registered using the ECA.care app was there. And that was the same doctor which I actually attended by surprise. Like, so it actually manages to match through all the intentional and emotions, what we call as synonyms in technicalities. So it in traditional database, it is like a matching things. We use a foreign key being matched with any other table, and we match it and return the data. But that's not always efficient. Nowadays, Google has Gemini and ChatGPT has its own embedding. Everywhere we use AI. I don't think we use like traditional database anymore to do search queries. So As I spoke about semantic search, it is nothing but intent-based search. So it actually matches with the meaning what we actually mean to search about. If we type doctor again, it returns a set of doctors, and if I say I have like a pain in some sort of area, and it returns certain specific specialized doctors. So it relates the data one by one. You guys getting what I'm speaking, right? So it actually doesn't depend on the exact words or synonyms which we actually do. And embeddings. Embeddings is nothing but, again, vectors. Like we have a string. This is hi, I am Ajay, and it actually converts it to the vector-based number, floating point numbers, which is a highly complexion of you cannot actually understand when you read it. I'll show an example of how it looks if anyone has doubt on vectors. Coming to that, yeah, so it actually enables the smart search results. This is a basic representation of semantic search. When I go into the code, you'll actually, guys, understand it better, I think. Yeah, so as you can see, guys, like embedding can be done on images, audio, text. And why embedding? Not normal text is because we have complex data nowadays. If we have huge amount of text to be stored in the database, we don't actually use SQL because it is not made. Like we actually store structured based data, which actually relates with another thing. We always use RDBMS for that. But when we use something which is unrelated, but it has a meaning for something, like I am a full stack developer, and I may be a different kind of a full stack developer using React at the front end, but he may be using like other framework. But we relate each other when it comes to what we do. So that's the main way we actually use embedding for. Like, if you see the example over there, so React is a front-end library. So that's how we actually pass the payload when you have to, store it on the database. But when we do embedding on the certain string or data, whichever we have to pass, that's how it looks, vectors, like 0.12 and negative values, and it goes on, depending on the size of the data which we are being provided. Again, it can be audio, video, text, anything. So when the higher complexion of data is compared with the existing data which is being stored in the vector DB. So what happens is, the closer the number which we see in the vector, the highest the number of results. So as I say, doctor relates to physiotherapy, and it relates the data because he is also a doctor. Not intentionally he has to be, there has to be a keyword like doctor. He does something related to medical, and he relates to that. So that's how we do in vectors. We actually match the closest complexity of the vectors numbers, and we return the results. That's how even ChatGPT stores its data in OpenAI. So we have like similar text like React and Vue, like they relate each other, like React and Banana will fall apart, of course. It doesn't, if we have a language called Banana, it will surely like return something. But yeah, this is small example of React and Vue, like it relates to each other even if it doesn't contain React in it. So we have some small real world examples like documentation, search, and bots. As I told, like e-commerce, we all have sometime to build, like when we were in college, we have all built like e-commerce as a project. So when we do e-commerce, we'll just send the payload in the JSON, and we just match with the query like where, like synonyms, and we retrieve the data in the traditional search. But in terms of using like vector DBs, we don't have to do any queries anymore. But again, this is not something for very small applications. This is for something which is very huge and complex data, which we use vector DB. So yeah, that's the matching of algorithm. Like OpenAI has its own algorithm of embedding, which actually matches with the existing data which is stored in the vector DB, so that the closest form of data can be returned. For example, 0.1 to 0.34, let's say. There's nothing between that. It actually matches the data based on the closest complexity and returns the data. It's actually the closest complexion, that's it. Nothing complex. So in React, nowadays we always use Next.js as it is more advanced, but in React, how do we use it? Like as any other API, we call it. We just input the user inputs his search keyword. Then using Open API, we actually convert the text into an embedding vector, and we actually store the vector if we want to store it. And Pinecone, something like, it is specially made for complexion data, and it is nowhere related to RDBMS. So it can, it is like an index DB is what I can say. It is an index DB where it stores the data based on the indexes, and whereas when you actually retrieve the data, like match the data which what the user inputs, it matches the index first, then goes into the data to match the related strings. So it is way more faster when it comes to complexion search. In traditional way, when we use like React, we always use Node.js and Express to process requests, which I'll be demoing like using a snap code, like which I have in the further slide. So as I said, again, like vector is a list of numbers in AI search. Like the closest the vector numbers, the more results it is being returned. The farther the numbers are, the lesser they are returned. There's nothing which is fixed over here, but we can restrict the number of tokens which is being accessed in the Open API. That's how we limit the results. So yeah, it is way more faster than SQL queries because it doesn't use RDBMS to match the data and return the result based on that, because it creates way more time complexity. And yeah, as I said, it uses like a traditional way where we do where like queries to query our database, but we stopped doing that using vectors. It is a new kind of database where we actually query the DB with the related available data. Let's say developer A already hosted some amount of data which is being already fed into the database, and we have no idea about it. We always have to contact the other developer whether you have inputted some kind of related data, have you worked on it. But when it comes to vector DB, there's no tension of that. You store your own available data which you have to access. Later, it actually matches the vector, because each character is given its own vector values, which relates to the other vector values which is provided by the other developer. Let's say I used I in the beginning, I am Ajay, and the other person uses you are an Ajay. You and I, those are synonyms which we use to introduce a person. So that's how vectors are being matched, because it matches with the rest of the strings that are being provided. Yeah, so the basic way how it works, just to give you an idea again, like user enters a query and we query the Open API to get the vector bindings, that's the vector numbers, and we store it in the Pinecone. And whenever we have to retrieve the data, we actually again query the Pinecone to get the resultant data, which returns the vector bindings again. Whatever we pass to the Pinecone, right, it's going to be in a vector format. So it can also be a metadata and a vector format, but it is always better to store the metadata, that is the actual string provided by the user, and the vector numbers, which is being embedded by OpenAPI. We pass both of these parameters to Pinecone, which is actually stored in the DB. So even when the user actually queries something, we can send the metadata, the actual string which is being sent, instead of querying the OpenAPI again for the embedded vectors. So we can actually pass the string itself to get back the result. So there are many vector database available, but one of the best one is Pinecone, because Chroma is one of the other vector DB, which also uses embeddings, but based on the cost wise, it's the only difference which you have in vector DB comparison regarding Pinecone and Chroma. That's the only thing. Those are competitors, but we don't have much difference. But when it comes to Pinecone, it is very cost efficient, and I'll provide some certain GitHub links if you guys are interested, how it is being actually implemented. So as I said, it's a cloud native vector database, and if we pass a huge data, it actually converts into an embedding. It is way more faster without any relations to it, and it is ideally I can give, like, nowadays we do Ghibli picture, right? Ghibli is a trend which which is actually going on, and the conversion of the data and story, we retrieval RAG, which earlier I talked about, right? So what we are doing is we are actually providing the access to our data to the AI. So by the data which we provide access, right, it's actually getting learned. And when it learns, it actually stores the data in terms of vector into the vector DB. So that's how it matches, even if you don't feed the data. The same example, developer A stored his data. We don't know what is stored, but we are going to store it again, and it matches the exact data. Like, let's say we convert our actual photo to a Ghibli picture, and we use the Ghibli picture again to make it to look like a real picture again, back again. Nowadays, it's not much efficient, but we actually look, when we do actual reverse image graphication, it actually does that, making the picture look back real again. That's how it actually works. So the like the fastness, like the scalability of this data, right? How it actually happens is only because of vector bindings. There's not much strings happening over there in the database match. So Pinecone actually uses something called hierarchical navigable small world. That is like, we first match the index before matching the actual string. We store the data into the vector DB in the vector array, but it has an index. So when we actually match with the index, we get the vector-based bindings, which actually returns the data way more faster. It doesn't look out for any other related data. Let's say we have 100 dimensional arrays, like hundreds of arrays, and we have like array 1, let's say just like array index 1. And in array index 1, we have related data to introduction, introducing something. It may be a product, it may be a person, it may be a something like a company, whatever it might be. If we are introducing something, the introduction related data is stored in the vector database in the position 1. So it matches with the index first, which actually inverts itself to return the contents of the array. So that's way more faster in terms of this when it compares to RDBMS. Yeah, so coming to the project structure, before that, I'll actually tell you guys like how it actually works. But for just a simple example, many of you have a doubt like, what if I have like huge amount of data? Is it free in the first place? This embeddings in Open API and vector DB like Pinecone, are these things free to access? Pinecone, yes, when it comes to a single developer for just using for its testing purpose, it is free. We have a free edition like starter pack, which actually allows us to match the metrics. So yeah. So, but when it comes to Open API, we have something called tokens. Tokens are the number of words. Based on the number of words, the cost is going to be scaled. That's how Open API can be called. So yeah, like this small example of semantic search. As you can see over here, we are just, when it comes, we are doing searches in backend. We have an Open API package, which we usually install using NPM package. But when it comes to vector, this is how it looks. The embedded data when we actually get returned by the Open API. We send the string to the Open API, and that's how the vector is being returned by Open API. We store this exact format of data into Pinecone so that whenever the string is being matched, it actually matches with the embedded vector core. But the problem over here is the user doesn't know how to pass the embedded data, right? So he actually passes the string again as the payload. In that case, we have something called metadata, which is one of the other parameters which we include when we are actually storing into the database. The actual string and the vector, both are stored in the database. These can be made possible only when we are using complexion of data, like huge number of images being stored. But it is less cost efficient. Open API doesn't allow that anymore. So coming to I'll move faster regarding that. Yeah. So I'll just give a quick review of how it looks. So we have the usual structure of how it is, how the code structure looks. And as we can see over here, I have created a separate function over here, which actually gets the embedded data from OpenAPI. For this to have access, you should have a token, which is actually being purchased by one of the API requests. So we pass the usual token and the content. Let's say the input over here, which we see. Let me see. So the input, these are the both like the payload which we actually provide for the embedding. So we actually provide the actual text, the search text, and the version of the model that we use. OpenAPI again has two models based on your requirements. One is 003 and 002, and 002 is usually used for mostly less visual data and more of text-based data. This is more less cost efficient. That's why we use this model. When it comes to more visual and audio video related data, we actually use 003. So as any other normal API, we just like pass the payload and get back the embedded vector. There's nothing much complex. But when we actually pass it to Pinecone to store the vector into the vector DB, we actually store the embedding, that is the vector payload. And top K is number of tokens that you are being passing when it comes to refresh tokens. We sometimes have caching capability for scalability issues. It is a more deep topic when it comes to storage of data. By what kind of tokens are you guys using in storing the data, in terms of storing the DB, and what plan have we choose? Like it, because vector DB works on nodes, number of nodes that you actually access. So for, let's say we have a huge database and very big company, and no, that's not a normal data. We actually pass 5 tokens. So there are 5 normal tokens, 1, 2, 3, 4, 5. Usually when we use 1, 2, 3, and that is for normal data like text again. When we use 5, it's for huge enormous amount of data. When we had to return like a big paragraph of data just by the word doctor, it returns everything related to doctor. Yeah, include metadata again, the string, the vector and the string. We store both of them. So we don't have to go back to OpenAPI again to get the embedding vector back when we are actually retrieving the result from the DB. So yeah, as usual, we implement in the components as any other normal components we do in React. But the only thing is there is no state management which we have to do when it comes to uh, writing the queries. Like, we actually store many environment variables in terms of accessing a traditional database. The only thing we use here for just for the sake of maintaining temporary available data of query which we are entering, the string which the user is gonna enter. So there's no environment variables which are very complex to be included. The only thing which we use is the token from the OpenAPI and the token of the VectorDB Pinecone. So there's not much to see over here. This is just a visual representation of how I had implemented it. I would have done a live demo, but the token for mine has been expired for OpenAPI. Yeah, I had to do a normal screenshot for the same of how it looks. So it's just a quick review. I'll provide like a Pinecone API key is what we stored in our env and the token of OpenAPI. These are only two things which are used to query a database and retrieve from the database. It might be a huge amount of enormous data. And why we use it? Finally, again, if we have an e-commerce store to be built and we just type fruits and it returns everything related to fruits. Even we can have a blog about fruit. It returns everything which is being stored in the VectorDB, which actually searches throughout the internet. We actually can, if you go to ChatGPT, it has a new feature called search. And it actually searches through the web to return the result. So that's one of the vector features. So putting all together, I can, that's not much, like we are just mapping the results. So the one of the last thing which I had to remind you guys about is, yeah, this is the GitHub URL, like which my friend had done using the semantic search. So I can provide you guys the URL for the same. It is a very interesting thing. If you have to build any new projects, you can actually use this same kind of methodology to build your own semantic search and intent-based search. And you can probably expand your possibilities of image search, audio search. Build your own AI possibility. So finally, we have our key takeaways. It is just a short topic after the break. So jotting down again, what we learned today is vector search, that is not just a keyword search, which is actually enables the wide capability of intent-based search. And it actually matches with the human-based emotions, which I can say. I'm sad, so it returns every possible, like it returns medicine, it returns doctors, it returns like where you can make friends, like Meetup app, it returns everything. That's called like human emotional related data being returned. And we use Pinecone to store our VectorDB related data. And we have OpenAPI's embedding model. The only thing is we have to measure the number of tokens which we include in our projects whenever we have to like configure in our own way. So my best suggestion would be using 002 because most of all we use like normal data, even if it's a large image, let's say a mug, which is being stored in the product as a product in Amazon, right? So until unless we have a big Amazon, we use like 002. And yeah, in the last, like it is used for smart document search and which are actually used in ChatGPT. And that's how we actually get the results from ChatGPT. Like, these are the only few things which I had to present about the VectorDB. Why VectorDB again? It's for huge and enormous amount of data, which is actually relating to a set of data which humans react like. I say, hey bro, and he tells me everything about his life. That's how VectorDB works in common sense. Yeah, so yeah, thank you guys. Thank you for listening to my talk. Yeah. Yeah, this is my contact details.
Would you like to go for a few questions from your side? Anybody? I think, yeah.
While you're embedding, how do you specifically manage to rearrange the results that we get from that? Because after you embed, then you do the cosine search and then you get the results, right? So let's say I get 4 results. Now it will be by its own order. How do I manage to change that orders?
That is a very vast question because that is we don't have to do anything about that because vector DB is based on index search.
From a particular product scenario, let's say I need to rearrange how it is basically returning the results.
It is not arranged. And actually, when we both are working in the same place on a same project, and you pass certain data and I pass other data, it is not arranged. It is in a random order, but
I want
the
to-
strings are being matched.
I want to predict that order.
They have specialized algorithms. Again, if I had
Thanks.
like the HNSW, the hierarchical navigable. If you just